Physics is me, you, and us. Why do we study it? How can we understand quantum mechanics, relativity, the Big Bang Theory, and our universe? All of this and more are discussed by Dr. Niseem Magdy at the YouTube channel Nisentron.
So actually, I followed closely your online courses at Stanford. I will say this is one of the best for the physics education.
Oh, thank you.
Very, very deep knowledge. Usually, I really enjoy it. And one of the courses that I really enjoyed was the quantum mechanics. And my usual question that I usually get from my audience, so we try to, I would say, we moved from the Middle East, Arabian countries. I'm from Egypt originally. Now I'm doing my second postdoc at Stony Brook University, United States. And we try to reflect back about the main questions we get usually from people in this region. And I think one of the questions is what you think, in your point of view, is the biggest mystery of quantum mechanics? What's the most mysterious thing in quantum mechanics to Leonard?
Well, there are so many of them. It's hard to focus on one particular one. And sometimes questions are so confusing and so, what shall I say, confusing. That's the only word I can think of. That it's really hard to tell if they're even questions, if they're really good questions or not. Questions like consciousness. What makes consciousness? That's not a quantum mechanical question, I don't think. But still, it's very hard to imagine exactly what an answer would be. Quantum mechanics is very confusing. It has this strange many world aspects to it. Quantum mechanics is statistical, and because it's statistical, it means that probabilities branch, that possibilities branch. We're sitting here now, and every time I make a tiny little decision about what to say, according to quantum mechanics, in some sense, the world, or at least the wave function, branches and branches into branches, most of which probably sound pretty much the same way we're hearing it now. But with some small probability, I say blah, 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 or I say kick, kick, kick. And those branches, do they constitute part of reality? Do they constitute part of the world? Or are they just mathematical fictions and the real thing is what we think we perceive? So there's many world aspects of quantum mechanics. The way probabilities, not just probabilities, but the way that possibilities branch and create many worlds of different possibilities. This is extremely confusing. We don't really use quantum mechanics that way. We make predictions and we predict the outcome, and the outcome is statistical. And in a laboratory, we don't worry very much about all these questions, but they're there. And another way to say it is it's very hard to understand in quantum mechanics what is real, what is reality. Does reality really mean anything in this world where all there are probabilities? So that's a very deep question. I don't know that it really will ever be answered. So if we came to questions now, which I suspect will be answered.
Okay.
Well, there's a lot of them. Can a quantum computer be built? Or is there some deep obstruction that we haven't figured out yet? How does quantum mechanics connect together? There's, of course, how quantum mechanics connects together with gravity. I haven't included that because I think we're making definite progress on it now.
Yes.
So I think that is going to be, at least in part, solved. But the question about how quantum mechanics, together with gravity, fit into the cosmological world is still obscure. The ideas that we have for how quantum mechanics and gravity fit together never quite refer to the world as we know it, never quite refer to the expanding universe, never quite refer to the accelerating universe. They're always models which contain gravity, which contain quantum mechanics, but which are different in the real world. So how quantum mechanics and gravity fit together with the real world, meaning the world that astronomers and cosmologists and experimental physicists actually perceive in their experiments, we don't know yet. And we especially don't know how all of this fancy new quantum gravity stuff fits together with elementary particle physics. We suspect it does.
That's the expectation,
That's the expectation.
Yeah.
But do we have any direct good ideas about how to use the ideas of quantum gravity to solve the puzzles of particle physics? Of course, there are some people who do think they have a good idea. And maybe they do. Maybe they do. I'm thinking about string theorists particularly.
Yeah, it depends if you can test them in the
String
lab.
theorist has his own different version of it.
I think it will depend if we can test them in the lab and if we can.
Yeah.
I'm working here. Part of my group is working in CMS at CERN. The other part is here in United States in RIC. And then I think we still, on the energies we use, the part of tera electron volt or giga electron volt, I think we still, we need some time until we reach that level.